All right, as we start lesson 3.1 on page 71, representing proportional relationships, you did the are you ready stuff, and those ones that had the two fractions set equal to each other, those were proportional, and you had a cross multiply and divide. So proportional relationships is what this section is all about. So our essential question is, how can you use tables, graphs, and equations to represent proportional situations? And then the solution is, if the ratio between one quantity and another is constant, you can use tables, graphs, and equations of the form y equals kx to represent the relationship between the quantities. And as I read that, I discovered that I have an error. I need to fix that. Sorry. Here we have representing proportional relationships with tables. So we have a table and it says, in 1870, the French writer Jules Verne published 20,000 Leagues Under the Sea, one of the most popular science fiction novels ever written. One definition of a league is a unit of measure equaling 3 miles. They ask us to complete the table. So I'm going to look and see how they have a number here, the distance in leagues, and a number here, distance in miles. So these two are together. So it looks to me like for every 1 league, you have 3 miles. So for 2 leagues, you would have 6 miles. And if you have 6 leagues, you would have 18 miles. So it looks to me like you would take the league and multiply it by 3 to get the mile. Multiply by 3, multiply by 3. This one, what do you multiply by 3 to get 36? And that, of course, would be 12. And then the last one, multiply 20,000 by 3, and of course you get 60,000, which is hard for me to write in there. Okay, so you complete the table. What relationships do you see among the numbers in the table? Well, as was stated previously, the relationship is the miles, the leagues. You multiply leagues by 3 to get miles, or you can say you divide miles by 3 to get leagues. So I'd rather say I multiply 1 by the league by 3 to get my miles. So I'm going to put down, oops, better write that in there. So every number in miles is 3 times the number of leagues. Now again, leagues is just a way to talk about distance on the ocean, and a league is about 3 miles. All right, part C. For each column of the table, find the ratio of the distance in miles, the distance in leagues. Write each ratio in simplest form. So I'm going to take the first one and write that in simplest form. So there's really not much I can do with 3 over 1. It's going to remain 3 over 1. So notice what I did was, it says find the ratio of the distance in miles. Distance in miles comes first to the distance in leagues. That was stated second. So the leagues number's on the bottom. It said use miles to leagues. So here we have 2. Of course, we have miles to leagues. So 6 is going to be our league. And I can reduce that down into 3 over 1. The next set, we have 6 and 18. So keep in mind that the leagues go on the bottom, miles go on the top. So again, I'm going to have 18, and that'll reduce again to 3. Whoops, I don't know why I did that. 3 over 1. And the last one will be 36 over 12. And that's, of course, 3 over 1. I lied. This is the last one. It'll be 60,000. And that, of course, will be also 3 over 1. Remember, you're writing these as ratios. You're writing them as ratios in simplest form. So a ratio compares two numbers. That's why I don't just write a 3 down. It compares two numbers. And then it asks you what you notice about the ratios. So let's look at all these ratios. 3 over 1, 3 over 1, 3 over 1, 3 over 1. And guess what? 3 over 1. So what do you notice about them? I would say that I notice they are all equal to 3 over 1. That's what I noticed about them. I hope you did too. Okay, then they have a reflect. So I'm going to zoom out of that. If you need to keep this up so you can copy it, then just stop. But I'm going to take this and I don't know what I'm going to do with it. Okay, got it out of the way. And I'm going to try to bring this over, turn it. It's very challenging. Oh, this is, of course, the, why I want to get the, this is the reflect. So number 1, if you know the distance between 2 points in leagues, so you know between 2 points in leagues, how can you find the distance in miles? And number 2 says, if you know the distance between 2 points in miles, how do you find it in leagues? So figure that out. Come back in a minute. Okay, so to get from leagues to miles, you multiply the distance in leagues by 3. To go from miles to leagues, you divide the distance in miles by 3. Please make sure you are using complete sentences. That's what I did. All right, on page 72, representing proportional relationships with equations. The ratio of the distance in miles to the distance in leagues is constant. Remember, it was 3 over 1 all the time. The relationship is said to be proportional. So if it's constant, it's proportional. A proportional relationship is a relationship between two quantities. In that case, we had miles and leagues, in which the ratio of one quantity to the other quantity is constant. And those were all constant. They were 3 to 1. A proportional relationship can also be described by an equation of the form y equals kx, where k is called the constant of proportionality. So the x and the y represent points on a plane, no, points on a line, and k is your constant of proportionality. Sometimes it is useful to use another form of the equation, k equals y over x. We may not see this quite as often. This is probably going to be much easier for us to use. Okay, so here's example 1, and again, we're still on page 72. Megan earns $12 an hour at her part-time job. Show that the relationship between the amount she earned and the number of hours she worked is a proportional relationship. Then write an equation for the relationship. So the first thing you're doing is making a table. Now, the number of hours controls how much she earns. So the hours, if she works a certain number of hours, she gets paid the money. She doesn't get paid and then work the hours. So the hours worked is our independent variable. We can kind of say that's going to be the number x, and then the amount earned would be the number for y, because y depends upon the number of hours worked. How much she earns depends upon how long she worked. So if she makes $12 an hour. In 1 hour, she has $12. 2 hours, $24. Just multiply 2 times 12. 4 hours, $48, and 8 hours is $96. So the number of hours times 12 gives you how much she gets paid. For each number of hours, write the relationship of the amount earned and the number of hours as a ratio in simplest form. So what they did is they took the amount earned compared to the number of hours. Now it's very important that you read this carefully. It says write the relationship of the amount earned. They talked about the amount earned first. That goes on top. The number of hours is a ratio. So the number of hours was second. The number of hours goes as your denominator. So that goes on the bottom. They took 12 and 24, 4, 48, and 8, 96. And notice they all simplified to 12 over 1 because for every hour she works, she gets paid $12. Since the ratios for the two quantities are all equal to 12 over 1, the relationship is proportional. So it asks you to write an equation. So when you write the equation, remember how they had the equation written down before as y equals kx? So our x and our y, they keep changing. They keep changing. But the constant of proportionality, 12, stays the same. So the equation is y equals 12 over 1x. But let's simplify this. Y equals 12x. So that means for every hour she works, you multiply it by 12, and that's how much she'll get paid. So x was the hours worked, and y is how much she would get paid. Okay, so here's an additional example. Now, this is not in your textbook. I just had an extra example. Marco earns $36.50 per hour as an accountant. Show that the relationship between the amount he earns and the number of hours he works is a proportional relationship. It should say then write an equation for the relationship. So I need to fix that. Oh, me and my typing. La-di-da, la-di-da, dagnabbit. There we go. All right. So the first we want to do is to make a table because according to the problem we just did, that was step 1. I guess I'll just figure that out. So this is going to be hours worked, and the bottom's going to be, I guess, how much he gets paid. How's that? Because my big fat fingers, I can't do this. Okay, so let's pick some hours that he can work. Let's see, 1 hour, 2 hours. Let's do 4 hours and 8 hours. So Marco, if he works 1 hour, he gets $36.50. So 36, oh, crying out loud, $36.50. And for 2 hours, he'll get 72. 2 times 36.50 is 73, not 72. Oh, I should probably not do this when I'm tired. Okay, then 4 times 36.50, so it's going to be 4 hours times 36.50. That'll be $146. And then 8 hours times 36.50, that'll be $292. Okay, so obviously the more he works, the more he gets paid. And then step 2 was to write this relationship as a ratio and compare them. So I'm going to have the dollars being divided by the hours worked. So 36.50 divided by 1, 73 divided by 2, 146 divided by 4, and 292 divided by 8. So this is 36.50, this is 36.50, this is 36.50, and this is 3650. These iPads are not big enough. So let's see, they also want us to write an equation for the relationship. So keep in mind that this is your X number, this is your Y number. So Y equals 3650 X. And that would be your equation, which you could have gotten if you understand what's going on just from right there. But that's okay. One step at a time. You'll get it. Okay, you try your turn, and I'll be back. Okay, so this is what I did, is I did the number of hours and then the bikes. I just chose these numbers randomly. And for 1 hour, they make 15 bikes because that's what it told me in the very first sentence. For 3 hours, well, 3 times 15 is 45. 5 hours, 5 times 15 is 75. So I made my table to help me organize. Okay, so the number of bikes made, it says the relationship between the number of bikes produced and the number of hours is proportional. So here I did my 1 hour, 15 over 1, that equals 15 over 1. My 3 hours, 45 over 3 is 15 over 1. And for my 5 hours, 75 bikes produced over 5 hours is also 15 over 1. So when I showed that all of these ratios are exactly the same, I can then go ahead and write my equation. So y equals 15x. Okay, here we have some guided practice problems. This is page 74. Vocabulary. A proportional relationship is a relationship between two quantities in which the ratio of one quantity to the other quantity is or is not constant. So we started this was on page 70, the top of the page, and I talked to you about proportional relationships. So hopefully you chose is. Those are constant. They is constant, I guess you'd have to say, because they have is, not are, is. Okay, the other vocabulary, when writing an equation of a proportional relationship in the form y equals kx, k represents the, that was also back on page 70. So k represents the constant of proportionality. Okay, good. Okay, so read 3. You want to complete your table, fill in your let x represent, let y represent, and then write your equation. Give it a shot. Remember, you make a mistake, that's a good thing because it shows me you're trying. Okie dokie. Write an equation that describes a proportional relationship between the number of days and the number of weeks in a given length of time. Complete the table. So 1 week is 7 days, 2 weeks, 14 days, 4 weeks, 28 days. You take your number of weeks and multiply by 7 to get the number of days. But here we have to divide. We're going to go backwards and divide. 56 divided by 7 is 8. Then 7 times 10 is 70. Okay, in this problem, let x represent, so keep in mind from what you learned from last year, x is going to be the independent variable and y is the dependent variable. And so when you have a table like this, the part up top is always the x. So the x represents the time in weeks. Y is always the bottom in a table like this. Let y represent the time in days. Write an equation that describes your relationship, y equals 7x, because the constant of proportionality is 7. That's your k. So y equals 7x. Very nice. That concludes day 1. Tomorrow is day 2. Stay tuned.